Oh,
Thanks,
thank you.
thanks for joining us.
Oh, it's my pleasure. It's great to be here.
I sat in awe watching those sites. Well, awe is the wrong word, but dumbstruck, with my
Yeah,
mouth wide open, thinking, "What on earth is going on?"
yeah, yeah. It
Incredible.
really was. It was shocking to, I mean,
Yeah,
everyone. There's no other way
yeah.
to put it. Um,
Mm.
and
And
we're still coming to terms with it, to be quite honest.
yeah, excellent. So I see we're about time to start. So let me welcome Ron from Microsoft along. As I said earlier, geography and maps have been close to the heart of Doug ever since it was started in 1998. And many of the original members were geographers to our hearts. And it's great to learn how Azure are developing their maps, because it's always good to see someone alongside the proverbial Google Maps that sit and invade so many of our lives. So the more we can see about alternatives and help some healthy competition, the better. So Ron, I'm looking forward to hearing what you've got to say. Thank you very much.
Thank you. It's great to be here, and thank you for setting this up, Gary and Tim and Jan. Really appreciate it. Super excited to talk to you guys. Are we ready to go?
Yep, yes,
All
yes,
right.
please.
All right. So just so everybody's on the call, my name's Ron Vincent. I'm a senior technical program manager on the Azure Maps team. So I'm actually, it's kind of an interesting thing, but we partner with the Bing Maps folks, but we do have two products at Microsoft now, and Bing Maps not being part of Azure, but Azure Maps is obviously with the name. So. It is a service that Microsoft has built, and it's a first party service basically, and it's a service that our Azure customers can make use of. So in this presentation, I'm just going to spend about 25 minutes or so talking about it and just talking about all of the different data services that you can use inside of Azure, and there's a ton of them. So this is going to be pretty quick, very high level. And of course, if you have any additional questions, we're happy to talk about them. So what is Azure Maps? It is you probably have, heard this in the cloud. You have infrastructure. In this case, you have infrastructure as a service, you have platform as a service, and you have software as a service. So Azure Maps is a platform as a service, meaning that it provides a set of APIs and SDKs it has for the last 4 years that Azure Maps has been in existence. It's been focused on developers. But recently, with some of our advancements including Azure Maps inside of Power BI, anyone can now use Azure Maps. And I'll show that in a minute. So Azure Maps, we actually, in order to help us get started and to get out of the business of building data ourselves, we partnered with these different companies here, such as AccuWeather for providing us with weather data. Move It, they're based out of Israel. They provide us with mobility data. So if you want to do things like find out when the bus is going to leave or when the train's going to arrive, or if you just want to route yourself from your home to the bus stop, from the bus stop to the train station or the subway or whatever you want to call it, you can do this with MoveIt's capability. We expose their APIs to Azure customers. And then, of course, TomTom, they're based right there near you guys in the Netherlands, and they actually moved to Azure. And so anyway, all of these companies, we expose their data and make it available to customers that do have an Azure subscription. And that's essentially what this is. It's a very different way of thinking about geospatial, because it is a platform as a service. It's not something you have to actually go and install, or you have to really do a lot of configuration and you have to do a lot of setup. It literally takes 5 minutes to create an Azure Maps account in Azure and you're up and running. So it doesn't have the traditional overhead that you see with geospatial technologies, where it takes weeks and months to implement them. This thing is, you're literally are up and running in 5 minutes, and you have an entire geospatial platform at your fingertips. So you get worldwide coverage with Azure Maps is essentially what I'm saying. So it's very easy to get started, start using these APIs and SDKs. And when we talk about them, we're talking about not only the ability to we have the ability to render maps. We also have satellite imagery, which I will show you in different geographies around the world, and also in different several styles. So you'll see the maps that I'll show, and they'll have different look and feel to them, and lots of capabilities there. We do have SDKs, so software development kits for both the web and Android. We have one coming out for iOS later this year, so you'll see that too. So if you want to build web apps, you want to build mobile apps, you can do that with Azure Maps. You can get started in just a few minutes and start building custom apps. And of course, you can do anything with those apps once you start building. And I'll show you that. I'll show you some of the samples that we have and drop a link in the window once we get done here. We also have the ability to do routing, so you can just do simple point-to-point routing from your home to some business or from business to business. You can do things like multi-algorithmic routing, batch routing. So if it's a trucking company, maybe you work in retail or you work in an organization that needs to deliver packages, whatever that is, you can actually do things like solve the traveling salesman problem. So you can enter in a bunch of locations and it'll figure out the optimal route for all of those places you need to deliver packages to, or whatever it is. So all of that is built into Azure Maps and it's directly available. You can even route cars, you can do trucks, buses, whatever you want. So all of those capabilities are built into them and they're just APIs. You make calls to them, it'll return the data back to you, and then you can visualize it. You can do additional analysis with it. You can run it in a machine learning model. You can do whatever you want with it. You can also convert an address to a latitude and longitude, so you can do geocoding. So it's a pretty common operation, but very necessary in order to have a complete geospatial platform. And we also have a points of interest database. There's 100 million points of interest. So if you're looking for a local store, you can search for it. If you want to find all the Starbucks, you can do that. It'll come back and show you where they are on the map. It can be landmarks and so on. You can also not only do search for a singular address, you can do batch geocoding too. So you can pass up to 10,000 addresses up to Azure Maps, and it'll come back and give you the actual latitude and longitude of each one of those locations. So it makes it really easy to map out things. So if you've got data sitting in a relational database and you want to geocode all of those, you can do that and do all kinds of fun operations on them. Such as spatial operations. So you can do things like figure out the distance between 2 points, see if a point's inside of a polygon. You can create what are called geofences based on time, distance, or whatever it is, or it could just be some polygon, a square or a rectangle. You can measure distances, even things between two locations, for example, from London to New York, and it'll create the Great Circle distance, which is obviously not the same thing as a straight line. You can do things like traffic and render that onto the map. You'll see here in a moment, I'll show you real-time traffic flow and the actual incidents on the map. And you can see that it's updated every minute, so it's that fresh. Much of what I'm going to show here is kept up to date. Matter of fact, those base maps that I'm going to show, they're updated every week by TomTom. As soon as they send out updates, we get them, and that means our customers get them. And they're out probing the world and sending us 600 million updates per year. So the maps are very fresh, very up to date, and it makes the maps very useful in that sense. You can determine which time zone you're in, for example. Many organizations cover multiple time zones these days, especially multinational organizations. You just want to route, create a route and determine the time of arrival for a package. You obviously need to be able to do that if you're crossing time zones. You can convert an IP address. So if you're trying to find out where a hacker is coming from, you can actually enter in their IP address. It'll tell you which country they're actually coming from. You can do things like mobility through our relationship with Move It. You can figure out when the bus is going to arrive, so you can get things like real-time intelligence and public transit services. So it makes it very useful. And this is a service that's particularly useful more so in the rest of the world than in the United States because most people in the US drive their cars, except in some of the larger cities. But in European cities in particular, the mobility services we have are extremely useful. Also, you can store your data up inside of Azure Maps. So if you've got some layers or some geospatial data and you just want to make it accessible, make it fast, you can do that with our data storage capabilities. We have a data API that lets you push that up there. And then the next thing here is the weather services. So on the map, you can see the current and predicted weather. You can actually see the precipitation on the map. You can see cloud cover. So you can see the radar. All of that will render right on top of those base maps. And that comes from AccuWeather. So we're literally taking AccuWeather's capabilities. We're taking MoveIt's capabilities and TomTom's. And we have some other partners coming on later this year. We've kind of mentioned this in some of our blogs, but we haven't made the full announcement. But we're going to have a new partner coming out, Airbus. So you're going to have freshly updated imagery. And in some places, in some cities, it'll be updated every 24 hours. So it's going to really change and how quickly you get satellite imagery every day. I mentioned too Power BI integration, so I'll show that in a moment. But many of the things that you see here, they're available now in Power BI, so anybody can use Azure Maps at this point. So it makes it really easy to create dashboards and reports. And in the government cloud here in the U.S., Azure Maps is also available. It's not really relevant to you guys, but it is relevant to our customers in the government. There's also Azure Maps Creator, and it is a geospatial publishing technology. And right now it focuses on indoor mapping. So you can actually do mapping not only of the outside world, but you can do it of the inside world. So you can map inside buildings. And so that adds a lot of amazing capabilities because now you can do things like show the inside of a building, render the different rooms and different styles. And later on this year, we're going to actually add the ability to do things like indoor routing. So you'll be able to route eventually from the outside world to inside of a building. So think warehouses, think distribution centers, think the supply chain. You eventually will be able to route from some location, for example, at a plant in China, all the way to some location and to the customer's doorstep in the US, as an example. So that indoor mapping capability is a huge new capability that we released back in May of last year. And just to give you a sense of what that looks like, we have a site here that shows some 200, now it's up to 257 samples. And as you scroll through here, you'll see there's a bunch of samples that show you exactly what Azure Maps can do. So let's just say you wanted to drop some points on the map, and it can be something as simple as the location of stores. So it can be something like here is a bunch of points on the map, and we're just going to put them on there. And it looks like I'm using a lot of my bandwidth right now. But so here's just a bunch of points, or these could be IoT sensors. They could be anything, and they're pulsating, meaning they're maybe the device is turned on or the store is open. It can represent anything that you can imagine. So these are just simple points on the map, and that's really all they are. Or it can be any number of different things here. For example, let's say you've got tens of thousands of points, and it's so much data that you can't distinguish the individual points because it's just so much data. So one of the things that you can do is you can cluster these points together. So here I'll just zoom in into Southern California. You see it says there's 357 points in that. As I zoom in, you'll start to see these points start to separate. So it's a great way to aggregate data to simplify it so that the human brain can understand what it's looking at. Otherwise, it becomes just a a giant pile of points on the map, and it's very difficult to see. So that's another thing that you can do. Or let's say you have some data and you want to render it on the map, and you want to render it based on some attribute, some field in the data. And in this particular case, these are earthquakes, and this is actually pretty recent. You can see these are the magnitude and the intensity of earthquakes around the world. So there's been some seismic activity here, and the size of these bubbles is dependent on the magnitude of the earthquake. So it's a great way to visualize data and to make it so that it's easy to understand, and it's very easy to set up. Also, much of what I'm showing you here, it's all open source. So you can go out on GitHub and you can see these exact samples, and there's all the HTML and the JavaScript. And in many cases, you can just grab this and start using it. You have to do a few little tweaks to make it work in your environment, but otherwise, it's that easy to just take these samples and get yourself up and going with Azure Maps. You can also if you don't like the base map that you're using, you can change it to any of the other base maps that we have available. And this is just a sample here that shows you, here's the basic base map. It's a street imagery, but if you wanted to change it to satellite imagery, we have a control here that allows you to add that to the map. And here we are in Seattle, and you can see the satellite imagery. If you don't like that, though, you can change it to some kind of dark theme map, or you can also change it to something that is even more useful to e-readers and those kind of things. So all kinds of possibilities. As you can see, it has some points of interest on here. It has the location of the roads and so on. So we provide you with all of this base mapping capability that we get straight from TomTom. Or you can rotate the map with these controls. You can tilt the map if you need to. You can, of course, we have zoom in and zoom out capabilities, or you can just use your mouse to do this too, of course. So however you want to interact and however you want to give your users the ability to navigate with these maps and to use them in all kinds of scenarios. Or you can do things like figure out how far a person can drive in a car in 15 minutes. In this particular example, near New York City, and you can see it's actually in Long Island City. But this is how far a car can drive from this location in 15 minutes. And of course, the traffic is awful in that part of New York City. But you can take, for example, how far can you go on a bicycle in that time? So you can almost get as far with a bicycle as you can with a car, just because of the awful traffic in New York City. So these are called route ranges, and we have the ability to calculate those and render them on the map. There's all kinds of other capabilities, and just to show you some other things here, especially since you guys are interested in data, here you have the unemployment rate, for example, in the US, and this is not current, so I don't know when this is from, but it's actually higher than that right now. This is the size of the labor force in each of the US counties, and you can compare and contrast two variables. So it's a great way to help people understand data by letting them swipe between this and look at different parts of the US in this particular example. Another example here is, this is population change. So here is an animated choropleth map. So these are US counties between the year 2000 and 2010. And if I just hit play here, you're going to see the population change. And you can see in the middle of the US, a lot of people left the center part of the US during that decade, and they moved into more urban areas. And that's been a trend now for the last 20 years. And using an animation, it makes it really obvious to understand what's going on here. So great way to visualize data and to understand what's going on. Or another example here is these could be 911 calls in this particular city. This is Fort Collins, Colorado. And we're just counting the number of calls that happen in each one of these little cells. So you can see where where the calls are coming from, just as an example. And that way it gives you a great insight on where should you place the next EMS, emergency management system, or where should you locate emergency services at so they could better serve those particular communities. So it's a great way to visualize data. And once again, this is all available here. You just click on the source code button and you can grab it and start using it. Lots of other examples, and unfortunately we won't have time, but you can do things like mark up the map. We have drawing tools. We support all kinds of geospatial formats, so you can use GeoJSON, you can use topological JSON, you can load in shape files, all kinds of geospatial formats. You can create heat maps. So if you have some data and you want to see the intensity of that data on the map, you can do that and render it in different ways. Or you can just use HTML markers and create something like a clustered pie chart. And that's a great way to visualize and understand data. All kinds of options there. Um, or you can do things like speaking, you guys are in London, or near London, around London. So if you just wanted to see the 3D buildings, we actually have those for that city. So there's the good old Tower of London, and you can actually look and see this particular area and get a good sense and gain some situational awareness about what's going on in that particular part of the world. Some other things here, we support all kinds of different languages. So if you wanted to display a map in different languages, that's possible. Um, and a bunch of other stuff like putting pop-ups on the map so people can gain greater access to the data. We have an elevation service now, so if you're looking at the elevation of a particular area, you can do that. You can get weather along a route. You can do waypoint optimization. So all kinds of possibilities here. You can do spatial analysis. For example, here is this thing. When we do our census in the U.S., we count by census block groups, and these are just areas. But for example, here is the state of Arizona, and I wanted to see how many people live in around this polygon around Phoenix, Arizona. So one of the things that I can do is just go and grab this little tool and drag a circle on the map, and it'll come back and tell me how many people live inside of this polygon. So it makes it very useful, very fast, as you saw, and I can see there's about 3.4 million people living in that area. So you can overlay the and visualize that data and do spatial analysis. We also support the Open Geospatial Consortium standard. So you have all kinds of ways of rendering data. Many organizations and other companies support the Open Geospatial Consortium. So you can take data from services that they've published and render them onto Azure Maps. So Azure Maps is very open in that sense. So for example, here is a layer that was rendered from the state of Texas. We didn't do this. They published it in the Open Geospatial Consortium format, and Azure Maps can take that and render it right inside on our web control. Bunch of other stuff here, all kinds of ways of visualizing data and understanding and using it to interpret what's going on. So it's very powerful. Like I mentioned earlier, there's traffic, so you can see that on the map. Makes it really useful for making real-time decisions. So if you've got to do some routing and based on traffic, you can see that in the map. So here we are in Seattle. I'll just click on a button and you will see the current traffic in that city. And you'll see that the lines turn green or red or yellow. And you'll see that there are incidents here like some roadworks and so on. So that's just a sense of what's possible with Azure Maps. But there's also a lot of other capabilities in Azure in general. And it's actually a pretty large list, but if you want to do more advanced analytics, you can get data from sensors and IoT, or whether it's from a file, a log file, or from media, or it comes data that comes directly from an app. We have orchestration tools like Azure Data Factory, which allows you to do ETL operations. You can store data for long-term in things like a data lake or in Azure Storage. You can put it in a Cosmos DB, which is a NoSQL database, or you can put it in a traditional SQL database like Azure SQL. You can do things like machine learning. We have things, services around Azure Machine Learning. We have GUIs that make it even easier with Azure Machine Learning Studio. You can use in-memory databases like Azure Databricks. We even have a data science virtual machine that comes with all of the data science machine, all the tools that you will need, the frameworks, etc. And then, of course, eventually you can containerize it and then use things like Hadoop, whatever you want, it's available. And then eventually you can serve it up and publish it and put it out there in applications or make it visible in a Power BI dashboard. I forgot to show that, so let me show this real quick. This is what Power BI looks like with Azure Maps. So as you can see here, I've got the city of Chicago, and these are neighborhoods in the city, these blue polygons, and these are bike racks. So you can see how many bike racks there are by the individual neighborhoods. And of course, this is an interactive map, so I can, tilt it, rotate it, do whatever I want. I can add other kinds of visuals from Power BI and summarize how many bike racks there are by neighborhood and see the total number of bike racks. And it really is just a matter of pulling in that data. And you'll see here, I've got the latitude and the longitude attached from that data set. So you can map out their exact location. And I've got the community names here so you can see the legend. Makes it really easy to create pretty straightforward and simple representations of that particular data. And to do even more advanced things, there's something that came out last year, actually just a few months ago. It's called Azure Synapse Analytics, and it really brings the best of everything that's happened over the past decade or so when it comes to big data. And when it comes to traditional databases, because you can pull in all kinds of different data sources and then integrate that in a variety of different ways. And then it will render and allow you to query data very, very fast. So it's an amazing technology, and then you can display it with Power BI. And machine learning, there's all kinds of capabilities. We have AI vision devices, speech, language, search. We have a variety of data science tools, just simple ones like Visual Studio Code or Azure Notebooks, which is the same thing as Jupyter Notebooks, but it's actually sitting in Azure. You can, of course, use command line interfaces. We have all the popular frameworks that are available, like PyTorch, TensorFlow, scikit-learn, and so on. And you can do things like using Azure Databricks to load the data completely in memory, so that way it's extremely fast. You can also use machine learning VMs to do this, and those machine learning VMs will come with CPUs, GPUs, and even FPGAs. So lots of possibilities there. You can also do real-time tracking, and this is a typical kind of architecture for using building these capabilities. You can have IoT devices. We have things like IoT Hub that you can send that telemetry up to Azure. You can use things like function as a service. You can, of course, render it on the map. You can do stream processing, build reports, and all kinds of other capabilities here. And just to give you some examples of what customers have done with Azure Maps, you see companies like ABB, they've seen a 20% increase in customer satisfaction using these technologies. Codasoft saw a 32% increase in sales. Rockwell Automation saw a $300,000 cost savings per day. Financial Fabric saw a 90% reduced time from documents to insights. And then Tall saw 40 times more insurance cases reviewed. And then UPS saw 200K customers interacting with chatbots. So lots of ways, lots of technologies that you can take advantage of to respond to customers, become more efficient, and so on. So Azure Maps, it is for enterprise customers. It's globally available. It has different SDKs. It works with other Azure services. The maps get updated weekly. The traffic updates every minute. And speaking of security and compliance, Azure Maps is compliant and has all kinds of security. We have an entire staff of people. Their entire focus is on security. We are GDPR compliant, which is great. You can integrate Active Directory, Azure Active Directory in this, so you have an identity as a service. Accessible, it's usable, it supports globalization and localization. We have some free tiers that you can use to get started with Azure Maps. There's no upfront cost whatsoever. You don't have to pay one pence or one penny, however you want to say it, to start using Azure Maps. So it's that straightforward. You only pay for what you use. And if you have any other questions, or if you need some additional links, there's some of the links to get to these various things that I just talked about. And if you want to contact us, you can just hit Azure Maps Sales at Microsoft.com, and we're happy to answer those kind of questions. All right, so I guess I'll open it up and see if anybody's got any comments or questions or anything else. Can't hear you.
Maps to begin with, didn't you? And you put me right very quickly, and then overwhelmed me with all sorts of different slides. I felt quite familiar at the end because only last week did I finally get my accreditation as a Microsoft Azure data scientist too. So I've been taken through that whole stream of things. So knowing that the maps sits in within that framework, it gives a lot of scope. Are there any other questions that people have at the moment? I can't see any in the Q&A.
There is one, Tim, from Stephen.
Is it in the chat, or is it
from Stephen Cook? We've come across issues in the past when using great circle distance arc length to accurate calculate distances around impassable terrain such as lakes or coastlines, etc. Does Azure Maps use the routing you mentioned to address this?
Yeah, we do have a service that will calculate the great arc distance. You can also pull in open source libraries to help you do that too. Those are always available to use, and Microsoft loves open source, so by all means pull in those tools to do that kind of operation too if what we have isn't meeting your needs too. So much of what we have is, matter of fact, our SDKs are completely open source, so you're free to use them and even make suggestions on what we've built. But you're also free to bring in open source tools and make those calculations that way too.
I think the question was, can the giant circle stuff not do the CrowFi calculation, but take into account physical obstacles? Is that? I think that's what was meant.
There is a way to do that because we recently came out with an elevation service. But if you wanted to calculate the distance or something like that, and there's a building in the way, we don't currently support that. Right. But that would be great to hear. If there is an interest in that, we would love to add it.
Cool. Okay. Thank you. Well, if there are no further questions, I know we've had an incredible day. Actually, I myself have learnt numerous things. As I say, we were fortunate right at 9:32 to be the first to get told the national summaries for COVID for the last year in total. It being the largest number of deaths since 1918 in the UK. I don't know what I suspect the US will have similar sorts of figures. It's been a somewhat extraordinary year in a number of different ways, in both ways. So, as I say, we heard it first at the Doug conference, and it was all over the 1 o'clock news, and I suspect it'll be all over the evening news as the first headline. This uplift, and I know I've listened to a number of my skeptical friends who have said to me before, wait and see, by the end of the year we'll have just seen that COVID killed off a few older people slightly earlier than they would have done, and this statistic absolutely demonstrates that definitely not being the case, and the people can sit up. There was also, I found it very inspirational for us as analysts to see how those particular analysts in the Office of National Statistics have been able to be so involved in government policy at a really critical time, and show how analysts don't just look at history. They have to be innovative in actually developing things anew and thinking on their feet so they can answer new questions as they come. And that's, from a completely different perspective, was what we saw with Tara when she was looking at the testing and the detailed medical inferences. And following on from that, having seen how the analysts have got to work with the current case, I was fascinated as well by the stuff Jeff told us this afternoon, how GDPR just continues to throw up a whole series of serious issues for us to address as we keep hold of the need to balance privacy with efficacy and put that into a sort of an ethical framework. And I think it's very good for analysts to sort of step away from the screen and consider not just what we can do, but why we should do something, and if we should do something, and what are those other implications of how we put things together, and how we can tie that to he used the phrase the individual, the community, and the society, and I think they're an interesting set of questions to ask us about the implications of anything that we do and we can raise. And then, thank you, Ron. At the end, you gave us a very quick sweeping. We clearly didn't give you anything like enough time to show the full capabilities of the examples, but that gives us tools both to execute at the high level, like ONS was doing, to get a sense of the overall impact at these different levels, individual, community, and society, and give us, as I say, that one of the remarkable things that's happened over this year is just showing how quick new answers and questions can be addressed at the moment within the data industry with a bit of creativity. It no longer is the case that people send off a request to an analyst and we're given 6 months to sort of set up a project plan to go and execute the data. We end up being right on the front line nowadays with all the sort of adventure and the responsibilities that entails. I think it was a while ago when someone talked about data science being the new sort of sexy job, but I think data analysts have become even more that case, and these few years have shown it, and I'm thrilled to be there and really enjoy encouraging others to take up this profession and all it can inspire us to do. So I always end by thanking Jan and now I'll add Gary, because they're the ones who bring this thing together and make sure it happens. I usually try and give Jan a bottle of wine and some flowers, but sadly I don't think I've even managed to get the post to deliver one this time, which is very remiss of me. But so I'll thank all the participants for coming along. Thank you, Ron, and I think the others speakers have already left, but I'll send them my thanks for contributing, and encourage you all to stay safe and but yeah, explore some data and throw up some insights, and as Gary mentioned, by all means, if you see anybody who you find inspiring in within the analytical world, please pass them on, and we'll see if we can share that inspiration amongst all of us, and be a place where we can help with our day jobs, but also lift our eyes to see where analysis works elsewhere, because I find it all very, very inspiring. Thank you very much to everybody for joining in, and I look forward to seeing you shortly in a new Doug meeting. Thanks very much.